In this demonstration, we'll see how Gloo Platform can be used to implement a service mesh zero trust architecture. This demonstration will include three components: a server API that represents a sensitive, protected service, a client API that has a legitimate need to access the server API and its protected data, and third, a bad actor that has exploited traditional infrastructure controls and gained access to the service mesh. First, let's observe the service mesh activity with no access controls in place. The three components are labeled ZTA server, ZTA client, and ZTA attacker. The green lines represent successful, active network traffic that is plain text and not encrypted. In addition to lack of encryption, these requests are not authorized or authenticated. We can see that both the client API and the bad actor are able to access the sensitive data owned by the server API without encryption, authentication, or authorization. Now let's apply a Gloo Platform access policy to secure our API. This policy defines the workload to be secured. In our case, this is the ZTA server. It requires that strict mTLS be used for access, and it also identifies which principals are allowed to gain access to the server API. The only principal that may access the resource is the ZTA client API. Let's apply this policy to our cluster and examine the traffic again. The policy has been applied to the cluster. The line between the client API and the server API is still green, but it has an mTLS lock icon now. If we further inspect, we can see it's using mTLS, which provides encryption and a strong identity that is being used for authentication and authorization. The bad actor has a red line, which represents active requests that are being intercepted and denied by Gloo Platform. To summarize, we started with an unsecured API that was accessed without encryption, authentication, or authorization. Then we applied a Gloo Platform policy to secure the API and observed that the bad actor was denied access and the legitimate client API accessed the server with encryption, authentication, and authorization using a strong mTLS identity.